Hello guys, I'm here with Megan Anderson, and she's a geophysicist with the Department of Natural Resources here in Washington State. And I'm just going to ask you a few questions.
Sounds good.
Could you tell us about what research you're doing right now?
So, in my work, I use geophysics to try to find and characterize faults that might create earthquakes, and in particular, faults that create earthquakes that are big enough to be a threat to our communities. And that's what I'm doing here.
Okay. You've been a scientist for a long time now. What inspired you to become a scientist?
Well, I remember that really well. When I was 5 years old, I lived in Kent, Washington, and Mount St. Helens erupted. And that made a big impression on me. And I just remember feeling an awe of nature that I was really interested in understanding. And I just didn't want it to be something that was off happening, in the woodland. I wanted to go and see it, and I wanted to understand it. And the way to do that is to become a scientist.
All right. One of the practices of science is using and developing models. When do you use that practice, and how do you use that in your research?
So when we're trying to find faults, we use different kinds of geophysical data, and we use the geophysical data in such a way that we're just walking on the surface of the earth and measuring changes that are due to the physical properties of the material below us. For example, we might measure gravity, or we might measure magnetics, or we might measure seismic waves. And when we get that data, we need to understand what it means for what's beneath us that we can't see, and that's the power of the data. So the way that we use modeling is that we create a hypothesis of the subsurface. What's down there? What does it look like? Where's the fault? What are the rocks on the other side? And then we use a computer algorithm to take that model and show what does it predict for, say, what the gravitational field would look like based on the density of the rocks. And then we compare that prediction to the actual data and see if we're right. And if we're not, then we change our model and try again until we have something that fits the data pretty closely.
All right. Thank you much, Megan.
Yeah, no problem.